Hey everybody, it's Hazel. Welcome back to ACE Tutoring and welcome back to another ACE Explains video. Today we're going to be talking about the empirical rule of statistics and how we can calculate numbers that are within 1, 2, and 3 standard deviations of the mean. So the empirical rule of statistics, I actually wish I had made a blank sheet for this, but no problem. The empirical rule of statistics is basically that when you have a set of values that form a normal distribution, that part is super important, that if you put these values into a curve, the curve would form a normal distribution, and usually the question will give you that information. And all observed data, or about all observed data, falls within 1, 2, or 3 standard deviations from the mean. So, the standard deviation is, remember, denoted by this fun little symbol. It looks like a tomato or an orange because it's like a O with the stem on top. And then the mean is the symbol that we also use for microgram. If you're taking chemistry or have taken chemistry, you might remember that that's the microgram symbol. So standard deviation and mean, those are the symbols for that. When we're talking about empirical rule, we're basically trying to calculate what values in a given data set will fall within the standard deviations for a mean. The best way to illustrate this is to draw a normal distribution curve. Third time's the charm. Okay, we want to draw a normal distribution curve. So, start like this, it goes up, and then back down. So a normal distribution curve looks like this. There will be a line here and a line here. The line in the middle that's toward the very top of the curve is the mean. And then there's 1 standard deviation on each side, 2 standard deviations on the other side, and then the 3rd standard deviation, which this is a little bit of a wonky line, but that'll be how it has to be. So in the center is the mean. Then we have 1 standard deviation from the mean and -1 standard deviation from the mean. So to get to 1 standard deviation, you add standard deviation to the mean. And then to get to -1, you subtract standard deviation from the mean, right? Then on the next set of lines is 2 standard deviations or -2 standard deviations from the mean. So you're going to add the mean to 2 times the standard deviation or subtract 2 times the standard deviation. And then on the outskirts is 3 and -3. And so it's mean plus 3 times standard deviation or mean minus 3 times standard deviation. So as you're finding the empirical rule, or as you're using the empirical rule, it's important to remember that for every line, you have to increase the standard deviation by a multiple. So the numbers closest to the mean will be 1, the numbers in the middle will be 2, and then the numbers on the outskirts of the curve will be 3. That is super important. You don't continue to multiply by the same multiple of standard deviation. You won't get the question correct. Okay, that's enough talking. Let's see if we can use some examples to figure this out. Oh, hold on. Hold on. We have to talk about the percentages as well. So the mean is like a standard 0%. The mean is where you start. On either side of the deviation lines, so we're going to start with the 1 lines, there is a 68% chance. It's better this way. There is a 68% chance of hitting the first standard deviation, a 68% chance. That means on either side, there is a 34% chance of hitting either deviation, making a total 68% chance. I'm actually going to move the 68 to the bottom and make it a little thicker so that you can see. So So there's a 68% chance of hitting the numbers that fall on or within the first standard deviation. And so that means on either side, there's a 34% chance. To move to the second tier, there is a 95% chance that you will find numbers that fall on or within the second deviations, meaning that on either side, there is a 95 divided by 2, which is 47.5. 47.5% chance on either individual side. And it is important to know the individual sides as well as the collective overarch. And then when you're getting to 3, and this is going to be a weird arch. When you're getting to 3, there is a 99.7% chance. The 0.7 is important, don't worry. There's a 99.7% chance that you will hit numbers that fall on or within the third deviation. So that means on either side, there's a 49.85% chance of hitting numbers on the third deviation. 49.85% and 49.85% on either side. So when they ask you to find numbers that are in the deviations, they will then ask you what is the percent chance that you will find numbers that fall between the mean and a certain value. You will use these percentages to answer those questions. All right, so here's our first example. Rat weights are normally distributed, which is a plus. We always want to solve questions that are normally distributed because that's the only way that the empirical rule can be fulfilled. And they tell us that the mean, that's the mean. They tell us that the mean is 6 and the standard deviation is 0.45. The first question is, find the percentage, so there you go, see they want that percentage. Find the percentage of rats that are less than 6. If the mean is 6, we are going to be finding numbers that are less than 6. So I'm hearing less than. I'm thinking, okay, we are going to be subtracting to get away from 6. The only places where we subtract are on this side of the normal bell curve. These are all the places where we subtract. So we're looking for our 1, 2, and 3, or actually I should say -1, -2, -3 standard deviations. So get your calculator out because that's going to help you with the calculations. So let's get started. So 6 minus 0.45 will get us to the first deviation. That gives me, I'm going to do this in black, that gives me 5.55. Okay? 6 minus 0.45 times 2. And the way I have it in my calculator is I've got 6 minus 4.45 times 2, just like that. And that gave me 5.1. So that number is also less than 6. And then the third deviation, which I'm going to put in my calculator as 6 minus 0.45 times 3. 0.45 times 3. That gave me 4.65. And so all of these numbers are less than 6. So that means on the left side, all the way to 49.85% is less than 6. Now you're probably like, how did you figure out that it was 49.85% and not 99%? Well, 99% covers the entire curve. That was a terrible arch, but you get it. It covers the entire curve, right? So for it to be 99.7%, it's got to be the whole curve. If it's just going to be half of the curve, it's going to be just half of 99%. So 49.85% is the best half that the calculator gave me. So that is the percentage of rats less than 6. Because going down the standard deviation curve, all of those numbers are less than 6. All right. Find the percentage of rats less than 6.9. Okay, So 6.9 means that they're actually starting with a number greater than 6. Greater than 6. So we need to add, we need to go to the right and find 6.9 and find that percentage. We will then add that percentage to the answer from the first question. So let's find the first standard deviation. We might have to find the second and third, but let's see. So 6 plus 0.45 is 6.45. 6.45. Now, 6 plus 0.45 times 2 is 6.9. 6.9. So, we found 6.9. It's right here in the second deviation. That means we're looking for numbers that include the first and second deviation, as well as -1, -2, and -3. So, to get from here to here, oops, that was erasing instead of plus. To get from here to here, you are doing half of 95%. Because to get to the second deviation, remember that that value is 95%. But since we're only on one side, it's half of 95%. So we're dividing it by 2. That is equal to 47.5% plus the number from the first question, since we're including all the values that we found on that half of the curve, plus 49.85%. So I'm adding those values together in my calculator, don't do this offhand, and I got 97.35%. That is the percentage of rats that are less than 6.9 pounds. All right, find the percentage of rats that fall between, these are another type of question you might get, a fall between question, 5.1 and 6.9. Okay, so we are looking at numbers that fall between the -2 and the 2 standard deviation. So that's 5.1 and 6.9. Remember, the number for second deviation is 95%. So numbers that fall within this arch, within second deviation, are 95%. So the percentage of rats that fall between the second deviation on either side is equal to 95%. Find the percentage of rats heavier than 6.45 pounds. That means that we are looking for numbers that are greater than 6.45. So, all numbers greater than 6.45 are going to fall on this side of the standard deviation curve. Now we already have our first deviation and our second. Let's find our third standard deviation. So it's 6 plus 0.45 times 3, and that gives us 7.35. Now we know, because we're on just one side, it's not 99.7, which is both sides of the curve, it's just half of it. So the percentage of rats heavier than 6.45 is going to be, actually want to slow down and make sure I'm doing this correctly. So we're looking for all numbers that go past 6.45. So it's just here. Okay, here's a challenge question for us. Here, from here to here, is 34%. From here to here, because that is half of 68, right? 68 is the first standard deviation percentage. When we are getting from here to here, we need to find out how much this is, how much this distance is. We know that this total distance from the middle to the second deviation is 47.5%, right? Because that's half of 95. So I'm going to do a little quick subtraction to find that missing piece right there. So right here is 13.5%. And then we need to find the distance from here to here as well. Now remember, the total distance from the middle to the third deviation is 49.85%. We don't really need this anymore. So again, I'm going to do a little subtraction. 49.85% minus 47.5 is 2.35. So here to here is 2.35%. And ironically, it gets the biggest line. This is not drawn to scale. It's 2.35%. So heavier than 6.45 means all of these numbers that fall under this black arch. So we're going to be doing 13.5 plus 2.35, and that gives us 15.85%. 15.85%. That's the percentage of rats that go past 6.45. And our last question for this video. Find the percentage of rats that is heavier than 8 pounds. Heavier than 8 pounds. Well, since 8 pounds goes completely off the standard deviation graph, remember our last number is 7.35, I would say that the answer to that is 0%, or you could say no numbers or no rat weights fall after 8. I don't know how to say that exactly. You could say that there are no weights that would fall past 8 pounds. Yes, okay, so I would say 0% of the rats, or yeah, there are no rat weights that fall after 8 pounds, or the greatest rat weight is 7.35%. It's all, you could say any of those, 7.35 pounds. I keep saying percent instead of pounds. Okay, I hope that makes sense for you guys. I know that was a little long of a video. Let me know if you have any questions in the comments below, and someone from our team will try to answer that for you. And as always, be looking out for more stats videos in the stats playlist on our homepage. See you guys next time. Bye-bye.